All right, so here we're looking at solving equations, but this time we're going to look at solving equations which have an unknown on both sides. And what that means is we're looking at equations like this, where we have 2x plus 10 equals 4x minus 6. So the problem here is that we have x's in two different places, which means we have to think a bit more carefully about how we solve them. But the method we use for solving them is the same as, it would be exactly the same as if this wasn't here and we just had an unknown on one side. But as always, it's probably easiest if I just do some examples to show you what I mean. So the first example we're going to do is 2x plus 12 equals 4x minus 8. Now, if we only had x's in one place, this would be a lot easier to solve. So actually, our first step for solving an equation like this is to get all the x's in the same place. Now, piece of advice, try to collect the x's where there's already the most of them. So you can see we've got 4x here and 2x here, which means the most of them are on this side. So this is where we want our x's to be. And there is a reason for that, which I might explain later. But we want all our x's to be on this side, which means we want to get rid of this 2x here. And we do that by taking away 2x, and that will just get rid of it. But as with every time we're solving equations like this, if we do something to one side, we have to do it to the other side as well to make sure it stays equal. So on the left-hand side, we have 2x plus 12 minus 2x. That just leaves us with 12. And on the right-hand side, we have 4x minus 8 minus 2x. Yeah, the 2x subtracted from the 4x, leaving us with 2x, and the 8 stays the same. And now it looks like this. We solve it just like we would any other equation. It looks like those slightly easier ones that we know how to solve already. We are trying to get this x by itself, which means we have to cancel out the minus 8, which we do by plussing 8. But we do it to both sides, as always, turning the 12 into 20. The 2x stays the same, and the plus 8 cancels the minus 8. And finally, we don't want 2x, we only want 1x. So we divide by 2, and x equals 10. It doesn't matter that the x is on the right-hand side, by the way. It usually ends up on the left, but it doesn't matter at all. That's it. So once it got to this stage, it looks a bit more familiar, and we can work it out a bit more easily. But the only thing you have to do to get it to that stage is to get all the x's in the same place. Let's do another one. Let's do 10x minus 4. Actually, no, let's not use x, because it's not always x. It could be any letter, really. 10a minus 4 equals 6a minus 20. So again, we're going to just collect the a's this time in the same place, so we don't have them split up. I don't want 10a here and 6a here. I want them all in one place. My advice from last time was to collect the a's where there's already the most of them, which means this is where I want my a's to be. So it's this that I need to cancel out. I want to get rid of the lower one. And to get rid of that 6a, I'm going to take away 6a. But if I take away 6a from the right-hand side, I have to take it away from the left-hand side to make sure it stays even. And that means my left-hand side turns into 10a minus 6a is 4a. The 4 stays the same. This 6a is now cancelled. That's gone because we took it away. So we're just left with minus 20. Right, and then we solve it like normal. We're going to try and get the a by itself, which means we're going to plus on the 4 to cancel out the minus 4, which turns my left-hand side just into 4a. And my right-hand side, well, minus 20 plus 4 is minus 16. And then I don't want 4a, I only want 1a, so I'm going to divide by 4, leaving me with a equals minus 4. I think I'll leave it there, but I'll talk through some more examples. There's a couple of questions at the bottom there. So if you'd like, you can pause the video here and have a little go at those, or you can just leave the video playing and I'll talk through the answers anyway. So pause here if you want to, and I'm going to talk through the answers. Right, so over here on this one, we want to collect the x's in the same place first, which means I want to get them on the left-hand side, because that's where there are already the most of them. I've got 7 on the left and only 3 on the right. So I'm going to take away 3x. What that turns the left-hand side into is 4x plus 5, and the right-hand side, the 3x's cancel, so it's just 20 left. Next, I'm going to take away 5 to start getting the x by itself, which leaves me with 4x equals 15. And finally, I'm going to divide by 4 to get x by itself, and 15 divided by 4, half it and half it again. 15 divided by 2 halved is 7.5, and half of that is 3.75. That might be a calculator question. And that's it. X is 3.75. And if we move on to the next one, I want to collect the a's where there's already the most of them, which is on this side, which means I'm going to cancel out that 2a by subtracting 2a from both sides. It turns the left-hand side into 12 and the right-hand side into 3a plus 6. I can then start getting this a by itself by subtracting 6 from both sides, leaving me with minus 18 equals 3a. And finally, by dividing by 3 to get minus 6 equals a. Now, one thing I haven't talked about is a way that you can check your answer. This is only something I would do if you have lots of extra time. You know, if you're left with lots of time to do lots of checking, because this can be quite hard work. But if we take this first example here and we do a check, well, the way we're going to do that is by taking what we think the answer is. We think x is 10. We're going to substitute it into the original equation, and we're going to see if the answer makes sense. I'll show you what I mean. So our equation is 2x plus 12 equals 4x minus 8. Now, if we think x equals 10, then we can substitute x equals 10 in for the x and see if the left-hand side is equal to the right-hand side. So 2 times 10 is 20, and 20 plus 12 is 32. 4 times 10 is 40, so if we take away 8, we get 32. And would you look at that, the left-hand side is equal to the right-hand side, so that means that 2x plus 12 equals 4x minus 8 when x equals 10, so our answer was right. That last thing you don't have to worry about too much, it is just a check. The real thing to take away from this is that you want to collect all the unknowns in one place. You want to get them on one side of the equation, and a piece of advice is that your life is easier if you collect them where there's already the most x's or a's or b's. So that step that I'm talking about there is where we chose this side to be where we want our a's to be, which means we cancelled out this 2a. And then when you've done that, you get to a point like this, which might look a bit familiar, and the equation is just much easier to solve. You undo everything that's happened to the x or the a or the b until you're left with that letter by itself, and then you'll know what it is. So that is solving equations with unknowns on both sides. If you're still a bit wobbly on it, of course, then just rewatch the video, and hopefully I hope that helped. Thank you very much.